Okay, hello guys, my name is Rami, and in today's video I am going to explain about Slater's rule. Slater's rule is to calculate shielding constant. Shielding constant is represented by, for example, S, and this is an important topic for NEET, and this shielding constant is used to calculate effective nuclear charge, right? Effective nuclear charge is equal to Z minus S. Z is nothing but atomic number and S is shielding constant. So to calculate effective nuclear charge in an atom, we need to know how to calculate shielding constant, right? So Slater's rule is for the calculation of shielding constant. So what are the rules for calculation of shielding constant? Let me write here. Okay, so for Ns and Np electrons, this is the rule for Ns and Np electrons, shielding value say for first of all we need to write the electronic configuration. Before this, write electronic configuration in this order: electronic configuration, energy order 1s, 2s, 2p, 3s, 3p, then 3d, like this. After 3d, 4s, 4p, and then 4d. After 4d, 4f, and this d and f must be separated from s and p. Then 5s, 5p, then 5d, and then 5f, like this. This must be the order for the calculation of shielding constant. So for Ns and Np electrons, shielding value is like this. For the electrons in N, the shielding value is 0.35. For the electrons in, let me write separately. N minus 1 electrons, the shielding value is 0.85, and for N minus 2 and others, the shielding value is 1. And for D and F electrons, the shielding value for N, the shielding value is 0.35. For N minus 1, shielding value is 1. For N minus 1 and others, N minus 2, the shielding values are 1 only. Okay, so let me give an example to calculate shielding constant. The question is, calculate the shielding constant for an electron in 2p of nitrogen, for example. So for this, we need to write the electronic configuration 1s, 2s, and 2p. This is very easy. So there are 7 electrons in nitrogen atom, 2 electrons here, 2 electrons here, and 3 electrons will be here. This is its n value, n is 2 here and this is n minus 1. So we need to calculate shielding constant for an electron in 2p, right? So shielding constant is how many electrons are left after removing that particular electron in concern. That is, here 2 electrons will be left and the electrons in this 2s, so 4 electrons will be left. So 4 into shielding constant of an electrons in nth energy level is 0.35 for ns and np electrons. So 4 into 0.35 plus, this is n minus 1. For n minus 1 the shielding value is 0.85, and how many electrons are here? 2 electrons. 2 into 0.85. okay, so this comes out to be this is 1.4 plus okay, 1.4, and this is right, this is 1.7. so 1.4 plus 1.7 is 1.4, 1.7 is 3.1. this is 3.1. so this is the value of shielding constant for an electron in 2p of nitrogen atom, right? So okay, so effective nuclear charge, therefore effective nuclear charge will be Z minus S. Z is what? Z of nitrogen atom is 7 minus 3.1. 7 minus 3.1, that is equal to 7 3.1, this is 9 and this is okay 3.9, right? 3.9, yes. This is the shielding effective nuclear charge on electron of 2p in nitrogen atom. So similarly we can calculate shielding constant for an electron in for a 3d electron of for suppose say iron, for example iron. Okay, so for this we must write the electronic configuration first in this order: 1s, 2s, 2p, 3s, 3p, this is 3d, okay, 4s, 4p, right? So iron has 26 electrons, 2 2 6 2 6, this is 18, then 20 here, this is 6. So this 4s electrons do not shield these electrons, right, in 3d subcell. So we need to calculate shielding constant for a d electron, 3d electron. So this will be our n, right? This will be our n minus 1 and this will be our n minus 2, n minus 3, like this. So therefore S is equal to, if I remove one electron from this 3d, then 5 will be left. 5 into, because we need to calculate for that particular electron of d subcell, right? So 5 electrons are left in 3d, and for d shielding value for nth shell is 0.35. 5 into 0.35, plus, how many electrons are here? 8. 8 into 1, right, plus this will also be considered as, n minus 2 and n minus 1, n minus 3. All these values will have a shielding value of 1 only. Therefore 8 10 into 1 only, right? So this gives 8 plus 10, 18, and 5 into 3.5, 1.75 plus 18 into 1 plus 1.75. This gives 1.75, right? 75 9 1. So this is 19.75. This is shielding constant for an electron in 3D subshell in iron. So if we need to calculate effective nuclear charge on an electron in 3D, then we need to subtract 19.75 from the atomic number of iron, that is 26 minus 19.75. okay, hope you guys understand how to calculate shielding constant and effective nuclear charge. Okay, thank you.